Hi everyone, thank you for joining me today. My name is Vijay Kumar Kola. I'm excited to present on the topic that is critical for modern enterprise AI powered testing, preventing SAP and Salesforce instant before they happen in the production environment. Enterprise instance often arise from inequident testing of complex SAP and Salesforce system. But here, the good news is this one: by leveraging artificial intelligence and machine learning, organizations can identify the potential failures before they impact to the production's systems. This approach dramatically reduces the testing cost while boosting the test coverage and the accuracy with along with the quality validations. Over the next 20-30 minutes, we're going to explore why this matters, the challenges we face, how AI can transform the test strategies. Let's dive in. Let's start with the big picture. SAP, S4HANA, and Salesforce are the backbone of the countless global business operations, powering everything from simple chain management, which is supply chain management, to customer relationship management. Now, with artificial intelligence over these platforms, think predictive analyticals in SAP, sales and distributions, metal management, finance, and transport management modules. So many modules. And or automated code to cash business process in Salesforce system. We are witnessing a revolution, but this revolution comes with challenges. AI introduce dynamic, adaptive systems that traditionally testing methods struggling to keep on. Considering the AI system in SAP automates the general entry to ensure with the SOX and GXP regulations. When we are talking about the SOX and GXP regulations, it's a very important for the compliances and regulator industry. A single mismatch could lead a significant financial losses or legal issues. Or a picture in Salesforce platform mispricing a contract, it going to be break the customer trust as well as it going to impact the revenues. These are not just possibilities, these are the real risks in the current environment today. The tradition testing, it's a static scripts with manual process, fall the short, and automation also, whatever the automation which we are doing, that is also have the some limitations with the test data as well as this one, the actions which we perform through automations. But because of AI algorithm evolve then over the time, this demands new approach with a continuous quality validations along with this one compliances regulations controls to maintain the data integrity and system performance user confidence. And coming, what does this means intelligent testing to bring in this table? It's a game changer. This approach leverages the advanced tool like Presentic Tosca robotic process automation, we also call as a RPA frameworks. An AI agent simulate the real world scenario, proactively identify the issues. In SAP, for instance, intelligent testing can monitor AI driven outputs across all the tracks like SEM, GTS, SD, MM. It's go on. It's all the tracks, including Salesforce. But catching the issues before they escalate. In the Salesforce, validating the price accuracy and workflow efficiency, the key factor in the customer satisfaction and business success. And it does not stop here. With the rise of generative AI, stakes even get even higher. The technology capable of creating the content of making decision requires testing the beyond the functionality. Now, intelligent testing not only verifying through validation but also verify the ethical AI use, aligning with the certifications like SAP AI ethics and mitigating the biases that could be otherwise it's a compromise the fairness. Without this, the we risk the deployment failure, compliances breaches, and loss of credibility that could be industry back. Let me share some real-time example, my own experience. Where I serve this as a senior quality assurance guy, we designed and developed few agents that generate the test score, execute the test plans in the tool. The agent will analyze this one, the changes, the live compare reports, what SAP transports, which is changes, and if coming back to the Salesforce, what GitHub pull request is, it how this automatically determines the regression impacts. This is one project where the our intelligent tool reduced the manual testing by 40 to 50 percentage by reading this one, the SAP changes, what are the changes they brought, what are the business process they're changing, what are those objects, and what are the Salesforce objects has been changing by going through this one pull request or change summary. By reading this one, our intelligent tool, well, intelligent testing related automation AI, it ensures this one we have comprehensive coverage for the AI enhanced future and the without overlooking the critical the compliances validation. If I going through further here on the intelligent testing, the the RPA bots, generally RPA bots we create for automating the repetitive rule-based tasks. The bots is mainly familiar with this one financial workflows such as general entry posting, accounting reconciliations, various analysis, and financial statements cross-check with a high precisions. But not only that, even the EDIs, electronic data interchange with sales order creations. The implementing of RPA bots in controlling testing, we are minimizing the human error and boosting the efficiency here. And the recent audits also, where the bots identify the discrepancies in SOX complaint test process and the manual review, it might be missed on this. And the SOX complaints is that manual reviews might be missed, the preventing the potential regulation is. Let's not to forget this Tricentic Tosca, where the cornerstones of the intelligent testing. I have used to build the automated regression test cases for multi-modules in SAP as well as Salesforce, for instances, upgrades, and the rollouts, where SD and MM, which is sales and distribution MM integrations, comes with a AI-driven automation. The Tosca module based allow us to simulate the n number of scenarios, detecting the defect early, accelerating the go live by the weeks. It's a in the especially on the logistics area. The real world application, it's not only ensure the seamless integrations and transitions from the legacy system to SAP, but also maintain the SOX and GXP stakeholders compliances. We'll give you with some of the examples here, how the intelligent testing safeguard our operations. Dive into this one, into AI, much faster and more reliable in the deployment. But here the question for all of us, are we prepared for this shift? AI become more embedded in our workflows. The demand of intelligent testing will only grow. The organization that adapts will lead the package. While this don't may fall behind. This is not just about technology, this is about the building trust, ensuring the compliances, unlocking the full potential of AI enterprise solution. So, what can we do first? Investing in the right tools, platforms like Tosca, RPA frameworks are this time. Second, trying the teams beyond the traditional testing, embarrassing the AI adaptability. Third, culture, which is continuous improvement, where testing is involves the technology. Now, the intelligent testing, it's just a technical requirement. It's a strategic imperative as well. Let's we go to the deserve to shape the future where the technologies empower us all. So what will happen if this intelligent, it will not serve this one? If you're not covering the major testing, what will happen on this? The main thing this one, the testing, if it's not happen, the impact will be on the business operations. It will damage this when your relationship with the customer. It stick the loss of the financial. It will impact the business. So that is the reason it's a very critical to have this intelligent testing. So far, we've gone through this one, why the intelligent testing is required and how that makes the difference on top of this one, manual testing and automation testing. Understanding the enterprise testing challenges. Now, let's break down the challenges first. The complexity landscapes like SAP environment. The SAP is having a multiple SAP system and also S4, SAP S4 HANA. It has a multiple modules that interact interdependencies, and also it's creating a cascading failure potential as well. In the Salesforce, another hand, bringing the extensive customization, frequent updates. The system rarely operates isolation, but this integrate with the legacy applications, external APIs, application program links, and the data warehouses. The tradition testing has a limits, where the manual testing creation is a time intensive, often misses the full coverage of the testing of the system interaction. On top of this one, resource constraints force the trade-off between the thorough testing as well as delivery timelines. On top of this one, the statics test suites become outdated as system evolves, leading graduation degradation of efficiency. So the understand here there is this each client, each business operation, the landscape as well as testing challenges will be different. I'll try to cover a few of them here. So as I mentioned earlier, SAP S4HANA and Salesforce are powerful platforms that drive the critical business operations. And AI right now we are using to enhance our testing efficiently become the forbidden challenges. I'll drill down on this. First, let's consider the scalability integrations, which we have discussed on this one, which is interacting with the multiple modules, which is thousands of transaction data flows across the global terms. Each transactions which we are driving that will create a number of table data along with this one that will impact with the SOX and GXP process controls as well. The Salesforce with the CPQ with a multi-cloud setup add the layers of customization where the price rules has been changed. Now, understanding this by going through this one S4 as well as sales code, they have challenges in the data dependencies. Both platform rely on the vast data sets. Like example, SAP for financial recognition, Salesforce for customer analyticals, ensuring this one data errors production without compromising the security constraint hurdle. In my experience, I've seen many projects where inconsistent test data lead to be missed defects in the integrations, which can be any SDMM, anything. Also, discovering the post go live, it will be costing to the weeks of rework and the project delays. The third one is one, the face of change adds the pressure. With a continuous upgrades, SAP has the releases, which is quarterly or service pack upgrades, and Salesforce has this one seasonal upgrades, which is winter, summer upgrades. Testing phase shrinking windows to validate the functionality. Like the certain duration, we need to test our entire functionalities in those two environments before it goes to the production. By adding artificial intelligence and automation into the mix, the challenges was intensified. AI-driven features like predictive analytics in SAP and automate code generation in Salesforce evolve dynamically and making the static scripts obsolete. This is evident where recent project where AI module adjustment in Salesforce required retesting 70% of the suite, stretching the timeline within. And whatever the example, we have undergone this one key issues. This lack of comprehensive test coverage. With the thousands of testcation, with a 5,000 per SAP module or Salesforce, this critical path is prioritizing the critical path is tough. Compliances requirement like GXP in any medical, medical or pharmaceutical or financial industry SOX demands 100% accuracy and the resource constraints often limit the testing for 70, 60 percentage or 70, 80 percentage coverage, leave the risk unaddressed on this. So what can we do? The first step is this one, adapting the intelligent testing framework. The tools like Tosca, present Tosca, which I've used, automate the regression suites, can handle the multi-modules in SAP. They reduce the 50 percentage of efforts. RPA parts, other tools which is implemented, automate the repetitive validation, ensure our consistency in financial framework. The second thing, this one, investing the robotic test data management. This test data can mimic the production safely on this. Embarrass the shift left testing, catches the defects early in CI/CD pipeline to keep the face of the updates. It is not only the about the tool, it's a strategy the team needs to be trying to understand these platforms. Must be prioritized the core investment, not on a after through. The defect gauging 30 percentage may prove very costly after go live on this. So by going through this one, e complexity landscape and traditional testing limitations, the instant to preventive actions, whatever the points we've discussed, it's need to be carefully, we need to address this information will be help on the our building this one AI and machine learning process. Now, AI and machine learning testing in the core technologies, the predictive analyticals for the risk assessment, machine learning from test optimization, NLPs, how we're going to do on this. So how do we address these challenges in the real time? So everyone, the usage of this one, this core technologies is vary. But let me put in article way how we can address these challenges, either entering AI machine learning. Let's, with the focus of this predictive analyticals for the risk assessment, machine learning from test optimization, and the natural language processing for the requirement analysis. Testing involved for a manual checklist for data driven sciences. And AI and machine learning are the forbidden of the resolutions. These technologies are reshaping how ensuring this quality in complex systems like SAP S/4HANA and the Salesforce, where error can have far reaching consequences. Let's deep dive one by one. First, predictive analytical for the risk assessment. This technology using a historical data, it could be the defect data or the issues in the production environment which we coming across, and AI modules to forecast where the defects are likely to be occur. Imagine you're doing a SAP S/4HANA upgrade or rollout with hundreds of modules and tracks, T codes, where a single update could be triggered the cascade of issues like a price example, price issue or currency issue. The predictive analyticals trained in the on the past defect patterns can prioritize the high risk areas like complaints, critical workflows under GXP, SOX, FDA regulations, Part 11. In my work, I have been seeing this action. A predictive model flagged for potential failures. A enhanced the sales and distribution module and inventory module to reduce the production deployment at least for 25 to 30 percentage during a recent upgrade. The next one, machine learning in test optimization. This approach leverages the algorithm to refine the test suites by eliminating the redundants and focus what it's matter. Tradition testing often involves thousands of test cases saying this one, take this one, S4 HANA, 1,000 test cases, Salesforce, 1,000 test cases may have recharged the outdated after updates. Machine learning analyzes the execution results to identify the most impactful testing, cutting efforts by 40%. As we discussed earlier, when the changes comes from S4, we're going to read the what the change is about, which object is impacting. Similarly, in Salesforce, we're going to read out on this one what is the change summary, our pull request is, what this code change for. By reading this one, when we implement machine learning driven tool that optimize your regression testing, cutting the unnecessary work at least for 40 to 60 percentage. On top of this one, they're shortening the test cycle from weeks to days while maintaining the coverage. This not only saves the time, but also adapt the dynamic nature of AI-driven future. Finally, the NLP that we call as a natural language processing for requirement analysis. NLP and interprets the requirement from unstructured text, email, documents, user stories from Zira or any format, turning inputs into precise or test cases. Sorry, precious test cases. The requirement, you can say this one, there's a blueprint or FTDs, function documents, or technical requirement documents, or functional requirement documents, or specs, any format in this. It will read this one data and it will be convert into this one into precise test cases. In Salesforce CPQ project, where the client requirements often evolved, NLP used 50 pages of specs, either functional technical specs or user stories, identify the key test scenarios to reduce the manual at least by 30 to 40, 30 to 50%. I've used this in my career to analyze the SAP notes, GitHub pull request, transports, live compare reports, or the objects list, ensuring this one we have a clearly articulated our test cases along with this one, the evident test conditions. This technology is crucial for managing the complex AI requirement, where intent context matters as much as code. Let's share the real world example. During S4 HANA implementation, prior to analyticals identify the high risk areas like a global trade system compliances due to A module adjustment. By focusing the testing there, we avoided potential regulator breaches. Um, and the machine learning also. Meanwhile, the machine learning optimize the test suite, cutting down the redundant test cases. NLP clarify the requirements from 20 pages change log, ensuring this one we have the full coverage. This combination prevented from delay that could have the cost of millions. So, but how does this technology work together? We're talking about the predictive analyticals, pinpoint the risk, machine learning, streamline execution, NLP, ensuring the alignment with the business needs. Together, they're creating the proactive testing ecosystem ideal for AI enhanced platform where the tradition method. The challenges, the integration of this tool requires the skilled team to robust the data pipeline, but the pace of is clear. The faster releases, fewer defects, and greater confidence. What next? Start by adapting this technology, increment the perhaps a pilot with a predictive analyticals for your next SAP updates. AI power testing strategies in SAP environment. We're going to break down this one our strategies, uh, SAP as well as Salesforce. First, we'll go with the focus on SAP environment. So when we are focusing with this one intelligent module with integration testing, automate the customization, impact analysis, performance, scalability, predictions. As we discussed, S4 is a very critical, powerful business functions we have with a complex integrations, frequent updates. The traditional techniques often fails a short. A stepping, it transforms the landscape, offering the targeted strategies to ensure this one reliability and efficiency. Let's this have a three key approaches here. First, intelligent module integrations. This strategy uses AI to validate interaction across all the SAP modules. Where change is one, like updating SD, can impact MM or finance. AI agent analyze the data flow and predict the integration points, reduce the manual efforts. We implemented by using a tool, Tosca, Presentic Tosca, and RPA, where an AI module tested between SD and finance integration and SD and MM integration for a inventory system. It caught the data mismatch during the pilot and preventing the post-launch failure and saves the rework as well. In the financial point of view, we have caught the defect on the group currencies and the conversions and also the reports. We found the defects that was helped us to avoid the rework in the production environment. The next one, the automate the customization impact analysis. SAP environments often feature custom codes. Think pricing logic, compliances rules for a SOX and GXP. AA automates the assessment how this customization reacts for updates and transport. A recent project we've used AI technology to analyze this one for live compare data, identify this one, what the changes on this, how this going to affect in our current business process, and how many test cases will be impacted. So we predict this one and we packaged by doing this one upfront itself. The regression team was saved 35 percentage of testing time by predicting and doing the early work on this. Finally, the performance and scalability prediction. This leveraged AI to simulate the load, predict system behavior under stress, critical for SAP real time demands. The traditional testing teams might miss how an AI enhanced SCM module, CRM module, handles the peak traffic. We deployed predictive model that forecast the performance during the high value with the maximum load. And we are revealing the scalability of bottlenecks and adjusting our configuration pre-launch, avoiding 20% slowdown. By proving this AI value, maintaining a uptime. We have some real-time example here. AI predicted demand data in SCM conflict with the stocks level. Automated customization impact analysis that flagged the custom GXP complaints as scripted need to be adjusted, while performance and scalability prediction ensure the system handle the 50 to 60% of traffic spike. Together, the strategy shaved. Together, this strategies shaved 2 weeks of testing cycle and ensured this one flawless go live. Why this matter? SAP's complexity, as we mentioned, and the thousands of transactions and few frequent updates, AI integrations demands the precise testing. The AI powered test strategies reduce the risk, optimize the resource, align with the business goals. The change, the integration AI required, robust data, the pay of the fewer defects, faster deployments. Now we go back to the Salesforce specific AI testing approach. There are three trailer made approach stand out. Salesforce specific AI testing approach, focusing on declarative configuration validation, third party testing, and user experience impact prediction. The Salesforce power custom centric operations worldwide from CPQ to multi cloud deployments and the integration with AI transforming how we can work. But this is brings unique testing challenges. Tradition methods often miss the issues. But by using a AI-driven future, let's explore these targeted strategies to ensure the quality and reliability. The first is declarative configuration validations. The Salesforce declarative tools, flows, workflows, and the validation enables the rapid customization, often enhanced by AI for automation. AI testing validates this configuration for accuracy. Edge cases. I used AI powered tool to test the CPQ pricing flow where AI module adjusted discount dramatically and the when I said this one dramatically or the based on the country, based on the customer, the setup, the price dynamically changes, and moreover, in the when the real time transaction is change when we are real time when trying to create the order in the back end, any user has been changing this one validations. The dramatically the system will review on that, and immediately the system will dynamically update this one. So we brought that situation where it's the scenario, and simultaneously we were checking this one the how this AI can adjust on this. This validation caught a logical error sometimes, the over discount of some 15 to 20 percentage, we prevented a revenue losses of 1,000 during this one pilot itself. This approach ensured this one configuration aligned with the business rules, even AI adapts them. Next, third-party integration testing. Salesforce often integrate with the external systems with SAP or payment gateways or marketing platforms where AI enhance the data syncing or decision making. AI testing simulate this interaction, detecting the failures at the boundaries. In project at in project, I implemented AI-driven testing for the Salesforce PAPO integration, where AI agent predicted data inconsistency during the peak loads. It's identified as a sync delay, allowing us to adjust the API calls frequency before go live, avoiding the customer facing issues. And finally, the user experience impact predictions. AI predicts how changes, new feature, AI enhancements, or update after an end user from sales representative customers. Using machine learning modules, it is analyze the user patterns and simulate this one UI impacts. I deployed this to assess the Salesforce CPQ updates with the AI-driven code generated. The prediction flagged with UI lag for mobile user, prompting the redesigning the improved customer satisfaction, scoring by 20 to 30 percentage post launch. This ensures this one the seamless experience in a augmented environment. Let's share some live example here. During rollouts, declarative configuration validation ensure this one the pricing rules worked across the region, catching the currency conversion glitch. Third-party integration testing validate the payment gateway link and preventing the transaction failures during a high volume sales. User experience impact predictions, confirming that updates did not slow down in the sales team. This leading a successful launch of zero deployment complaints. Why this matters? The Salesforce flexibility, there's thousands of configurations and integrations and user touchpoint demands. These AI approaches reduce the risk, optimize the deployment, enhance the user satisfaction. This challenges lies in the data quality and tool integration. This benefits the few defects, faster releases. Implementing the framework, building AI powered testing capabilities. Let's outline the framework. Let's start with this one, assessment and planning phase. Evaluate the existing testing capabilities, infrastructure readiness, and organization maturity. Align the stakeholders in objective and success matrix, ensuring this one system support the data needs. The next technology is stack tool selection. Excuse. Then data strategy module development, developing the strategies for data collection, storing while maintaining the security, using interactive, excuse me, for the continuous refinement. Finally, the integration with the existing workflows, ensuring a tool will measure the seamless with CI/CD pipeline test management. Sorry, the assessment of planning phase. So let's walk through framework step by step. First, as we discussed at the beginning, assessment of planning phase. What is this? What it does? Actually, this evaluates your current testing landscapes and the process skill gaps and identify the pain points like manual test coverage gaps, slow regression cycles. I lead the assessment for the S4 and uncovered 60% of test cases were redundant due to outdated scripts. This phase lets goals says reduce the defects by 30%, build a roadmap for the business objects for the compliances, SOX or GXPs, FDAs, and the speed. The next data strategies module development. AI. AI thrives on the quality data. So these steps mainly focus on gathering and preparing the data sets, test results, defects logs, user behavior, developing the AI modules tailor made to your needs, like predicting the risk and optimizing the test cases. We designed a module using a historical SAP S4 as well as Salesforce data to forecast defect prone areas, improving the test focus by 30 to 40%. This phase requires a clean and secure interactive mod tuning to reflect the real world scenarios. The third one is this one, the technology stack and tool selection. Choosing the AI tool fit your ecosystems. And we selected a few projects, Tosca, ML platform to enhance SAP testing, cutting the execution time. We did this one and the scalability of future growth on this. Finally, the integration with the existing flows. This step embedded AI testing in CI/CD pipeline, QA processing, and the team practice, the seamless integrations, which is reduce the delay of 20% defect quarterly improving on this. You can ask me this, why does this framework matters? Building AI powered testing is one of the project. It is a transformation. Without assessment, you risk misaligned goals. Without data and models, AI lack accuracy. Without the right tool, scalability suffers. And without integration, adoption stalls. The challenge is this one, balancing investment with the results, but the payoff faster, smarter testing and undeniable. How do we start? Begin with this one, some pilot project, assessment phase, focus on single module. It could be the SD or MM or finance. Build a data strategy, the accessible test data. Select the tool and integrate incrementally. The this phase approach cut down the data leakage 20 to 35%, showing a major success. The technical implementation requirement. During the technical implementation, needs the robust data. The key types including a historical test results, production logs, user behavior data, and the configuration. High quality drives data is crucial for effective module training. Anomaly deduction, data preparation, cleaning, labeling, sensitive information, ensure our compliances, module integrity. The foundation strategies are paramount for AI learning capabilities. Operationally, the seamless integration, which is key with the CI/CD sorry, with CI/CD pipelines. The test tool management, like you can say Zira or Qtest, and automation framework like a Selenium is critical. Scalability and performance and data security is vital, especially for the large system like SAP and Salesforce. Adhering to regulator like GDPR must be core part of the operation framework. Technical deep AI testing architecture. Let's take a deep look into this one architecture. The core AI engine has a three component. One is data registration layer, collects the logs, performance metrics. The machine learning engine process the data, testing intelligence. The i- the decision engine combines the insights and generate the actionable recommendation based on the business practice. The integration API first design the flexible tool chain and event driven the architecture for the real time responsive with the bidirections by enabling the backbone integration. So the main thing this one here we are doing on this one, the scalability relies on the distributing processing of the various demands, catching the performance, multi modules, or tell the business what they need on this. So the main thing this one in SAP and Salesforce, the core AI engines where you collect the information, that's based on that we are generating the predictive analysis that will enhance using this machine learning. We process this one, that algorithm that makes this one rule based decision, that the core components will go into on that. From there, we're going to integrate this one architecture platform. Then the scalability consideration will come. Risk-based testing and predictive analyticals, intelligent risk assessment, predictive failure analysis, dynamic test prioritization. Again, this will vary based on the which project you're working for, which your client you're working. The intelligent risk assessment module use the AI to access the failure probabilities. Again, failure probability, it will come considering this one, the what data you've been feeded, considering that complex business process, like each, as I mentioned, this one, each application, each business process critical, and how you customize by predictive failure analysis, enable the organization foreseen the failures modules by analyzing the code changes integration factors. So very important how you're feeding this one predictive analytics. Based on that, system start reacting. Dynamic test adjust the testing focus in the real time based on the risk and business needs to ensuring this one you have this one given this one right high, impact areas, and also the machine learning, especially the corrections we are giving enabling the proactive interventions. This will be truly shine your truly will enhance your AI, how you're building on this. So as I told you this one, based on your the predictive data, which is how you feed in how you feed your system. Based on that, the algorithm we need to build. Based on that, you will be paid off by caughting the defect much earlier in the production system before going to the production system. Automate the test generation and smart selection. Let's talk about the automation here. AI-driven test case creates the creation, uses the machine learning, analyze this one system specs, user behavior, generating the comprehensive test cases for standard and edge scenarios. So NLP translate the requirement to executable. At least for 30 to 40 percentage, we need to review and we need to adjust this one our rules, and we need to review our whatever the test intelligent test data generated, put this one the test conditions and feed our automated NLP, and based on that, whatever the data you are getting, make sure this one that is being maintained in very sensitive information, I mean sensitive way. Uh, the ensuring this one the integrity works well. The adapt to test suite optimization continuously refines suite by identifying the redundant test cases, coverage gaps, and generating the additional test case as we need. And this again, this is very continuous program. The system is keep on changes. The new rules will come. Some of them business process will going to be outdated. So this is a continuous improvement activity where you have to make this one automate test case generation and smart selection. Simultaneously, you want to bring this one your regression library, new cases. At the same time, you have to make sure this one you're redundant some of the test cases which is not you currently not in the business process and not useful for to identify the defects on that. So you have to enhance this one, then only your AA will shine on this. Self-healing systems, proactive monitoring on this. Here, here where it's exactly I mean, here where I'm exceeded here, the self-healing systems. So, autonomously, issue resolution uses the machine learning to identify the issue, and we are preventing the corrections uh, by using a AI vision, detecting the deviation with that signal problem. The continuous validation and monitoring prevents the ongoing health check, catching this one the issues. So when this is usually used to come across this one UI, like whenever this one the position of this one the fieldless length has been changed, our self healing system with AI vision it will go and it will be do the corrective adjustments, and so that without your communicating the system will we have driven the rules, and based on that it will go and correct this one and wait for our confirmation. Once we confirm on this one, and it will be implemented in this one regression library. So we made the checklist before implementing the one of our reviews will come on this one, and I'll confirm on that. This is again feedback loop integration enabled continuous learning, analyzing the test effectiveness, instant prevent success. This is how we are preventing even the instance in the production system. This is applicable for both S4 as well as uh, Salesforce. Integration with the CI/CD pipeline. As we discussed earlier, the seamless pipeline integration leverages the existing orchestration tool, standardizing API flexible across the architecture. The real-time the quality gates makes the intelligent deployment decision based on the test results and the risk assessment. Mainly, we are covering the business criticality. The automated rollback decision monitors the post-deployment metrics and triggering the rollbacks and the instant. The safe way decision aggregate. I mean, the safe net supports the aggressive deployment while maintaining the reliability on this. This main thing is this one seamlessly how you're integrating on that, how you're maintaining the real-time quality gates, and automate the rollback decision making on anything that safely we can maintain the deploy on this. Measuring success and metrics and ROI. How do we know it is working? Measuring success involves the quantitative metrics, improve the test coverage, early defect detections, reducing the testing time and cycles, fewer deployment issues, and cost savings. Qualitative and quantitative, we see enhanced developer experience, better product quality, increased team confidence, improve the risk management. Long-term value includes the faster innovations, market competitive, customer satisfaction, adaptive and new technologies. This matrix prove the return on investment of AI-powered testing. Here you go. The future of enterprise testing. Looking ahead, AI testing is shifting us from reactive to predictive approach. Advanced machine learning, like deep learning, will detect the substandard failure patterns, while cloud navigate the testing with a scale and microservices. Emerging integrations patterns, API first design, event driven architecture, and low code platforms will bring the new challenges and opportunities. Organization adapts these capabilities will gain the competitive advantage in the reliability and deliverable. The future is bright. I would like to tell you this brings us an end. Thank you so much for your attention. I hope you gained valuable insights how AI can prevent the instance in S4, SAP, HANA, Salesforce environment. I'm happy to take the questions, but as this is online, I'm stopping here. Thank you, everyone.